stereoisomerism. You know there are two different types of stereoisomerism. Number one, electrical isomerism. Number two, optical isomerism. Now I will discuss the geometrical isomerism. Geometrical isomerism are shown by the complexes where the central atom has coordination number 4. That means coordination number when the coordination number of the central atom in a complex is 4, we get two structures, two types of complex. One is quaternaire, another is tetrahedral. But cis-trans geometrical isomers are also called cis-trans isomers. You see, suppose that is A2B2 type complex. Example is PPCl2 NH3 all 2. This is the square planar complex of platinum. Platinum is the central atom. Coordination number of platinum is here 2. You see, we get the square planar complex like this. This is platinum. Here, these two chlorido. When the position of chlorido ligands are adjacent to each other, then it is called cis complex. Again, when these have opposite position, these are opposite to one another, this is called trans. But tetrahedral complexes do not show cis-trans isomers because the position of the ligands are close to each other in the tetrahedral complexes. You remember the square planar complexes show cis-trans isomerism. When the same ligands are adjacent to each other, these are called cis, and same ligands are opposite to each other, these are called trans isomers. These are the complex of the type Na2Bc. Here, if we have here 3 ligands are present: chlorido, amine, and pyridine. 3 ligands present. Here 2 pyridine, 1 amine, and 1 chlorido ligand present. Now we can write the geometrical isomers of this complex is as you see here, chlorido and 1 chlorido, 1 here, this is the cis complex where the 2 pyridine ligands are adjacent to each other. You see here the trans complex will be, this is here you see 2 pyridine ligands are opposite to each other, and these are different amine and chlorido. This will be the trans ligand and the trans complex. This will be the cis complex. That means when the only 2 ligands are same and another 2 are different, and this is called Na2Bc. So here A2 is PY2 and B is this, C is this. Then you can write the cis complex like this, where you create same ligands are on the adjacent position or same ligands are in the opposite position. But one important thing is that square planar complex, the complexes having where the coordination number is 2 and 3, they do not show the geometrical isomerism because the position of the ligands are adjacent to each other. Now I will discuss the topic geometrical isomerism of complexes having coordination number 6. You know one thing, that when the coordination number of a central atom is 6, the structure is octahedral. Here, if let us consider the complex this, where the coordination number of chromium is 6. Here 2 chlorido ligand is present and 4 amine ligand is present. Now, what will be the structure of geometrical isomers? One will be cis, another will be trans. Here you see there are 2 chlorido ligand, there are 4 amine ligand. We can draw the cis and trans isomers like this. This is the central atom. Suppose this is chlorido, these are amine ligand, 4 amine ligand. You put the where 2 chlorido ligands, you see the position of chlorido ligand. When these are adjacent to each other, this will be the cis isomer. Again, you can draw the trans isomer like this. You give now the chlorido ligands are opposite position, are in opposite position. This is the octahedral structure. This is trans isomer. Here, the same ligands are in opposite position. We cannot explain with respect to the amine ligand because there are 4 ligands. We can draw the cis and trans isomers with respect to the chlorido ligand. When these are adjacent to each other, this is called cis. When these are opposite to each other, this is called trans. The name of this complex where the same ligands are on the same side is called here tetramine cis, tetramine dichlorido chromium 3 ion. This is also called trans tetramine dichlorido chromium 3